So this is for a designer study, for a correlation. And you'll get a stimulus, which will be something like design a study to investigate the relationship between anxiety and the accuracy of eyewitness testimony. So if that's the case, if that's the stimulus, then that word relationship, that tells you this is a correlational study. So the bullets could be anything, like that you've got to include the information. So it'll say include information on bullet 1, for example, variables, a hypothesis and controls. Bullet 2, specialized materials and details of the procedure. Bullet 3, data analysis, including display of data and inferential statistics. So that's how you're going to get the majority of your marks, by making sure that you cover all of those bullet points with justification. But you also get marks on whether you can implement that study. So you've got to provide enough detail that it's obvious, like that if someone picks up that study, they can actually carry it out. And then you get marks as well for being coherent. So you've got to have a good structure. You can't just whack any old nonsense in. And with the designer study, you're going to have to write mostly in continuous prose to actually explain what you're doing. Okay, so before I hit those bullets, I'm just going to give the examiner a couple of sentences to say what I'm going to do. So I'd say I'm going to design a study to investigate the relationship between anxiety and the accuracy of eyewitness testimony. And to do this, I'm going to give all the participants a questionnaire to measure their anxiety level on a scale of 1 to 10. And then all participants will watch a video of a violent crime and be required afterwards to complete a questionnaire to find out their accuracy score. Now that tells the examiner that you know what you're doing. You're just measuring those covariables, which we'll talk about now. So then give yourself a heading that comes from that bullet point. So like that first one, wasn't it? Like variables, a hypothesis and controls. So your variables are covariables because this is a correlation. So you put covariable 1, anxiety score on a scale of 1 to 10. Covariable 2, eyewitness testimony score. Now you can see here both your covariables are giving you a score. So that tells you a clue for later, because that's ordinal data, that is. We'll come to that later when we talk about inferential stats. So you've given your covariables and now it asks you for a hypothesis. Now don't get mixed up with an experimental hypothesis. This is a correlation, so it has to be a correlational hypothesis. So if it doesn't specify whether it's directional or non-directional or null, just choose any. If it does specify, obviously follow those instructions. But a non-directional hypothesis would just be there will be a relationship between the anxiety score on a scale of 1 to 10 and your eyewitness testimony score. If you want to make it directional, you just add one word, and that word is either a positive or a negative correlation. So there will be a negative correlation between anxiety and the accuracy of eyewitness testimony, or a positive one, whatever you think. You should know it's a negative one, but there you go. I mean, not always. Think about the Swedish bank robbers. Anyway, I digress as always. So give the hypothesis if they ask for it. And then the controls. Now this is a correlation. So, you know, if it was an experiment, then you'd be using control measures like counterbalancing for repeated measures or random allocation for independent groups. But we've not got an experiment, so therefore we've not got experimental design. And that means we don't have those control measures. Now you can always use a pilot study as your control measure, because a pilot study is a small scale study done before the real thing, and it tests the materials and the procedures to make sure everything's working right and to make sure that everything's well controlled. So you could say, as a control measure, I carry out a pilot study, this small scale investigation before the real thing, and I don't care about the results. I just want to test those materials and procedures. So is the video shootable? Is it the right amount of time, or is it too long or too short? Has it got the right amount of detail in it? Is the questionnaire suitable? Do all the questions make sense, and are they actually measuring the accuracy of eyewitness testimony? Does the equipment work? Is it the right volume? Is it, has it got has the internet access work, and you don't want to turn up and try and show a video and then the internet doesn't work? So you're testing all these things, and that controls the real investigation, because everything's working and everything's the right amount of time and everything measures what it's meant to. So you could say that. And if you really want to go to town, you could introduce another control measure, which is standardized instructions, because that can be used for any investigation, and it controls for investigator bias, because the investigator might have an idea of what they want to see and give off subtle cues and clues to certain people. So if you've got standardized instructions, that does away with that investigator bias, and it means everyone gets the same crack of the whip, as it were. Everybody kind of gets like the same idea of what they're doing and how to do it. So you can do that. Second bullet says, what did it say? Standardised procedures and some details of the procedure, and underline that. So the specialised materials and apparatus, that's your shopping list. What do you need to actually carry out this investigation? So you need video of violent crime. Maybe, you know, if it's on the internet, you need internet access, or, you know, a screen and speakers, something, and you need the questionnaire and the pen, or you might have, you know, you might get them to do the questionnaire on a phone, on an app, or on a tablet. But you say what materials you need to carry out this investigation. And then details of the procedure. Now, you don't have to go to town here, but you just might say something about the procedure, like participants would all fill in this questionnaire to assess their anxiety score on a scale of 1 to 10, and then they would watch a video of a violent crime for like 10 minutes. So make it realistic. You don't want a video for like 2 hours, because they'd lose the will to live. So anything between like 10 minutes and half an hour, the tops, would be, you know, okay. So you'd have like how many participants, you know, you've got 20 participants, for example. That's what you're aiming to get. And you might say, like, you know, get them through a volunteer sample, because that's ethical, because this is about anxiety. So everyone's going to watch that crime, and then a certain amount of time later, say an hour later, anything an hour, 24 hours, that's fine. They come back and they fill out that questionnaire to test their accuracy of eyewitness testimony. So you're giving them a little bit more detail there, just to give them an idea of what they're going to do, so they can replicate. So say how long the video is, say when they come back to be tested. So that gives you 2 scores then for each person, their anxiety score and their eyewitness testimony score. Okay, third bullet, data analysis, including display of data and inferential stats. So you would say, you know, I've got my data, and I would draw a table to show that you're going to record that data in a table that shows pairs of related data. So what you need is a table, and it has 2 columns, that, you know, and both the columns are labelled with one of the covariables. And then on the left hand side, you've got a little tiny column which just says participant number, like 1, 2, 3, 4, 5, 6 down to participant 20, whatever. So you would say that you would record the data in a table where each person gets 2 scores. Draw that table, and if you want, put some data in. Like, so you've got to think about it though, because if you've said people are being tested for anxiety on a scale of 1 to 10, then each person needs a score between 1 and 10. You can't be putting like a score 500 for anxiety, because we haven't tested that. So put some data in if you want, but then underneath that table, say I would then move that data, or I would then use that data to put it into a scattergram to show the relationship, the association between those 2 covariables, and get an idea of whether there is a relationship or not. So draw a scattergram. Now, do not waste your time putting all the data in. Just like put some dots in to show that you know what a scattergram is. Give it a title, label the axes, and you might like show that it's got like a positive or a negative correlation, whatever you want, or no correlation, doesn't matter. Just put the dots in. So you're saying and displaying that data in a scattergram because I'm showing the association, like possible association. And then the inferential stats, you would then say it's a test for significance. I'm going to use an inferential stats test, inferential statistical test. And the one I'm going to choose is Spearman's Row. So we've chosen Spearman's Row because we've got ordinal data, and say because we've got 2 scores. You know, we've got the eyewitness testimony score, we've got the anxiety score, and those numbers are ordinal data because they're numerical. but they don't have a specific unit of measurement like time in seconds or anything like that. It's just some scores. And then Spearman's Row, because it's a test of association between the two covariables of anxiety and eyewitness testimony score. And then it's also ordinal data, test of association, and it's got pairs of related data, which you can see in the table above because you've drawn that table. And so that Spearman's Row will test for an association between the variables, and that's it. So don't complicate it. Don't start trying to control anything. With a correlation, you simply measure the covariables, put the data into a table, transfer that to a scattergram, and then you would do a Spearman's Row test. Now, we don't even have to do the statistical test. If you do geography or biology, then you're probably going to have to actually carry out statistical tests. We're lucky in psychology, they don't ask for that. They just say, which test are we using and why? Tell a lie, sometimes we do the sign test, but that's like, you know, super easy, so it's not a problem. All right, good luck.